Translations of sine and cosine. So again, back to our transformation rules. A horizontal translation shifting a trig function left to right is called a phase shift. So the phase shift of the function a equal a sine k theta plus c, or cosine k theta plus c, is c over k. If c is positive, the shift is to the left. If c is negative, the shift is to the right. So another way to write the function would be to write it as a sine k times theta plus c over k. So if you factor out the k and you write your function like this, this is the k that you use to find the period, and then this is your phase shift. So this is the way I write it a lot of the times. Factor it out so that you can read off the phase shift. And if I give you a phase shift, an amplitude, and a period, and I want you to write the function, writing it this way is perfectly valid, and you don't have to distribute anything. So the phase shift for each function, in this case, phase shift is pi, and because it's plus pi, that is going to be pi to the left. Positive is to the left, negative is to the right. It's the opposite of what you think it should be. Here, for cosine is 2x minus pi over 2. Right? So our phase shift is going to be pi over 2 over 2, right? This is c, this is k, phase shift is c over k. So pi over 2 is pi over 4. And because it's negative, it's pi over 4 to the right. We could also write this function if you wrote it as 2x minus pi over 4. Then here is your k, and here is your phase shift. And so here's the graph. I can erase this so you can see things. Here, this was pi to the left. So the original function is in blue, and we shifted it over by pi. So this purple function, right, the point that was here now is shifted over here. And the point that was here now is shifted over here. And the point that was here now is shifted over here. This one, our phase shift was pi over 4 to the right. And so the cosine of 2 theta, right, that's with the period of pi instead of period of 2 pi. But then we shifted it over by pi over 4. And shifted over by pi over 4, and shifted over by pi over 4. When a constant is added to the end of the sine or cosine function, the graph is shifted upward or downwards. So basically you just add whatever that is to the y value. This gives us a new horizontal axis known as the midline, to be the reference line or the equilibrium point about which the graph oscillates. So the graph y equals a sine x plus h, the midline is the h part. So the vertical shift and the equation for the midline for the function 2 cosine x minus 5, then graph the function. The minus 5 is the midline. So the vertical shift is minus 5 is going to be 5 down, right? Negative is down, positive is up. The equation of the midline is going to be the line y equals -5. Equation of a line is going to be y equals. So here's the function. Now the midline is -5, so instead of going, so the amplitude is 2, we go 2 up from the midline and we go 2 down from the midline. So instead of being up and down from the x-axis, now it's up and down from the midline of y equals -5. Say the amplitude, period, phase shift, and vertical shift for y equals 4 cosine x/2 plus pi minus 6. Then graph the function. So the amplitude is 4. The period is 2 pi over k, where k is 1/2. Right, that's k. So 2 pi over 1/2 is 2 pi times 2 over 1 is 4 pi. The phase shift is c over k. This is c. Our k was 1/2. So pi over 1/2 is 2 pi. And our vertical shift is -6. So that's 6 down. Our phase shift was a positive, so our phase shift is to the left. And so the graph of it looks like this. So this dotted one here is 4 cosine theta over 2 minus 6. So shifted down 6. It's got an amplitude of 4, so it goes up to -2 and down to -10. And it's got a period of 4 pi. So it starts here and goes like this over the course of 4 pi. And then we do the phase shift. We shift that over by pi over 2, and now it goes like that. Write an equation of a sine function with amplitude 4, period pi, phase shift pi, -pi over 8, and vertical shift 6. So, amplitude 4, right? That's going to be 4 sine. The period is k, right? And k is 2 pi over the period, which is 2 pi over pi, which is 2. So put the 2 here. X, our phase shift is minus pi over 8, and a vertical shift of up 6. That's it. That's all you need to do, right? You could also distribute this 2, and that gets you 4 sine 2x minus pi over 4 plus 6. But you don't have to do that, and that is extra work, right? Do it with the 2 sets of parentheses, don't distribute, and then you've got your k and your phase shift, and that's very easy. If you only have 1 set of parentheses, you need to distribute. If you put 2x minus pi over 8 plus 6, if you write this, I will count that wrong on a test. All right, if you don't put the 2 sets of parentheses, you have to distribute that too. But it's easier if you put 2 sets of parentheses and you don't distribute the 2. First rule of math, don't make it harder on yourself. Compound functions, we're not going to be tested on this. I just want you to know that they exist. They can be sums or products of trigonometric functions. They can also be sums and products of trig functions and other functions. So sine x times cosine x, or cosine x plus x. You can graph compound functions involving addition by graphing each function separately on the same coordinate axes and then adding them, right? So you've got, this is your cosine function, and this is your line of y equals x, and so then you add the amounts, right? And so you do the cosine is this much above the, it's basically using that diagonal line as your midline. You can find a few critical points and then sketch the rest of the curve. We're not going to do this. It's not going to be on your test. And that's it for 6.5. Almost done with this chapter. Yay!